All right, so here we go with day one. Starting this new unit, Unit 5, Systems of Equations. I'm not going to go over all of your notes with you, but there were a few highlights that I wanted to hit here since this is the beginning of a new unit. What a system of equations is, by definition in your notes, it says a set of two or more equations using the same variables. So we're going to have two equations. Today in our first lesson, they're both going to be in slope-intercept form. And that kind of leads us into why we're going to be solving them by graphing. And the way that we know what a solution is, what the right answer to a system of equations, it's going to be the one point, an x comma y, that makes both of those equations true. Today we're going to be solving systems of equations by graphing. And so in context for us, we're going to be looking where those two lines intersect. And down at the bottom of that first page of notes, you're able to identify how many solutions a system of equations can have. So just by looking at their slope and their y-intercept. So looking at their equation, we can tell how many solutions it's going to have. If your two lines have different slopes, it's only going to have one solution. It's going to intersect in one spot. If they have the same slope, we talked last week about if two lines have the same slope. What are those called? They're what kind of lines? Parallel. So they're going to be running side by side. Are those ever going to cross each other? Whether they're straight up and down, whether they're diagonal, are they ever going to cross each other? No, they're not. So those are going to have no solution because there is no x or y where both equations could be true. With that being said, what if they are the exact same line? Same slope, same y-intercept. They're relying on the exact same line. That means that it would have infinite solutions. At every point, it's true for both lines because it is the same line. So let's go ahead and look at some examples about how to solve systems of equations by graphing. During this unit, I'm going to be using two different colors a lot. That way you can just kind of see what I'm talking about. You can identify the two different lines. So in our first example, we're going to have y equals 3x minus 3. And we're going to have y equals negative 1/2 x plus 4. So we do need to kind of take back to our last unit about how do we graph lines. If you'll look at your steps for today's lesson, we're going to have to graph lines. First step is to plot the y-intercept directly on the y-axis. So I'm going to start up here with this top line. So here's my y-intercept of negative 3. So that means I go down 1, 2, 3 and make a dot. From there, I'm going to do rise over run with my slope. Since my slope is a whole number, I put it over 1 to make it into a fraction. So I'm going to go up 1, 2, 3, right 1, up 1, 2, 3, right 1, up 1, 2, 3, right 1. I could also go the other direction, down 1, 2, 3, over 1, and now I'm running out of graph. So I could connect these points. Guys, it's important to be as accurate as possible. You can use your notebook as a straight edge, you can use a ruler, you can use anything that you've got around you to kind of help you make that straight line. Because the way that we're going to know a solution is the exact point that these two lines cross. So it's got to be at a coordinate, okay? So now to graph our second line. Here's my y-intercept. So I'm going to go up 1, 2, 3, 4, make a dot. My slope is negative 1 over 2. So it should be going downhill. So I'm going to go down 1, right 2. There's my point. I'm going to keep going just for the sake of graphing my line. Down 1, right 2, down 1, right 2. I could go the other direction, up 1, left 2, up 1, left 2. Now whenever I make my line, I can see that right there is their point of intersection. So the solution to this system of equations is this coordinate, which is 2, 3, because it's always x comma y. So it's 2, 3. And that's my solution. Let's do another one together. Let's say that I have y equals 1/4 x plus 1/2. And then my second one is y equals 2/3 x minus 2. Now then, some of you might have gone into panic mode because you're like, oh no, there's a fraction back here at the back. That means I can't do it. No, guys, it's okay. Fractions happen. Where would 1/2 be? You would just go up right in between 0 and 1 and make a dot. Plot your y-intercept directly on your y-axis. From there, do rise over run with your slope. So I'm going to go up 1 over 1, 2, 3, 4. Up 1 over 1, 2, 3, 4. Running off the graph just a little bit, probably more realistically right there. I could go down 1 over 1, 2, 3, 4. Down 1 over 1, 2, 3, 4. Once again, do your best to make it as straight a line as possible. You can see I kind of started missing a little bit. So on this second line, I'm going to start at -2. From there, do rise over run with my slope. So I'm going to go up 2 over 1, 2, 3. Up 2 over 1, 2, 3. I could go down 2 over 1, 2, 3. Down 2 over 1, 2, 3. Whew. This might get tricky, y'all. So now I'm going to draw my line. I am betting that if I drew a straight line, right here is where they would have crossed. So you can see now why it's so important that you draw a straight line, and this is what happens whenever you don't. So our solution to this system is going to be 6, 2, because it's the point of intersection. Okay? Let's do another one. Let's say I have y equals -x plus 3 and y equals -x minus 3. Already you may have noticed something different about this equation, or this system of equations. They both have the same slope. So already I'm kind of thinking, well, that sounds familiar from my first page of notes. But let's see why that's true, why that happens. So if I'm graphing this top line, I start with my y-intercept. So I go up 3 and make a dot. From there, if there's no number, what do I assume that it is? A 1. And then I can put it over 1 to make it a fraction. So I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. And I'm going to go until I run out of graph. And I can go in the other direction as well, doing our best to make a straight line. Miss Lowball would be so disappointed. And then down here, I go down 3, make a dot, down 1, right 1. And I can go in this other direction as well. Doing our best to make a straight line. Are these lines ever going to touch? No, they've got the same slope. They're parallel lines. So where's this one's point of intersection? It doesn't have one. So this one would be a no solution. No solution. In your notes today, I gave you an example of one that would be an infinite solution, where they were the same line. And the top one had the slope of, I believe, 2. The bottom one had a slope of 6 over 3. Well, guess what that simplifies to? 2. So they ended up being the same line. If you need to see that, it is done for you in your notes. If you have any questions on today's lesson, feel free to shoot a text. See you guys.